Okay, example 1. Find all the zeros of x to the fourth minus 4x cubed plus 8x squared minus 16x plus 16 and write the polynomials of product of linear factors. So basically this is what chapter 3.3 was all about, finding all the zeros of a polynomial function. Whatever the power is, the highest power is, that's how many answers we're going to be looking for here. We do want to find all the zeros, meaning both real and complex zeros, and so if there's an imaginary answer, which is going to happen today, we want to list those also. Alright? And they do say to write the polynomials as a product of linear factors. All that means, let's say the answers are 1, 2, 3, and 4, x minus 1, x minus 2, x minus 3, x minus 4. So just write it out in factored form. It's always, when you get an answer, it's x minus the answer when you write the polynomial form. So, whatever the power is, in this case 4, there's 4 answers. You want to find as many answers as it takes to get down to a quadratic, 2 answers, and then the quadratic formula goes from there. That's the technique I would always use. So looking at this polynomial, dealing with the Cartesian, what was there?
Descartes rule.
Yeah, Descartes, yeah, there it is, Descartes rule. I had Cartesian in mind. Yeah, Descartes rule for signs, we start there. Alright, so 1 sign change, 2 sign changes, 3, 4, so there's either 4 or 2 or 0 positive solutions. If you look at p of negative x, only the odd powered signs change, so x to the 4 stays positive, 4x cubed changes to positive, 8x squared stays positive, 16x changes to positive, 16 stays positive. We can see there's no sign changes there, so there are 0 negative solutions. So now when I do my p over q here, I don't worry about the plus or minus, I only have positive answers. So for the possible rational roots going on here, and notice also it's 1x to the 4th, so it's just p over 1. So it's just whatever the factors of p are. So plus or minus, or sorry, it would be plus or minus. So positive 1, positive 2, positive 4, positive 8, or positive 16 are the only possible rational roots to this problem. Then I go to my y equals, and I try to determine some answers here. So x caret 4 minus 4x caret 3. Remember, every time you hit the caret key, hit the right-hand button to get out of that power level. Plus 8x squared minus 16x plus 16. I'm going to go to my table. I only want to find 2 answers, so I'm going to stop once I get 2 answers. If I put a number in here from that list of numbers and I get 0 out, that's an answer. So try 1, I got 5. Try 2, I got 0. Try 4, I got 80. Try 8, I got 2,448. Try 16, I got 50,960. So there's only 1 answer out of those 5, which implies that answer is going to happen more than once. It's going to be like x minus 2 to the 2nd power, maybe 3rd or 4th power. Okay? So once I establish that 2 is the only number that works out of my list, I'm going to do synthetic division with that. So 2 goes out here, 1, negative 4, 8, negative 16, and 16 go over here. It's the same process we used from chapter 3.3. Bring the 1 down. 2 times 1 is 2. Negative 4 plus 2 is negative 2. 2 times negative 2 is negative 4. 8 minus 4 is 4. 2 times 4 is 8. Negative 16 plus 8 is negative 8. 2 times negative 8 is negative 16. Plus 16 makes 0. My remainder is 0. My reduced polynomial is now x cubed minus 2x squared plus 4x minus 8. I'm assuming 2 works again. Bring the 1 down. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. 4 plus 0 is 4. 2 times 4 is 8. Negative 8 plus 8 is 0. Remainder 0 implies that 2 works twice. My reduced polynomial now is going to be x squared plus 4. So this is q of x, if we want to name it like we've been naming it so far, the quotient after synthetic division. If x squared plus 4 equals 0, that means x squared is equal to negative 4, which means x is going to equal plus or minus the square root of negative 4, which is going to be plus or minus 2i. And those do count as answers, 2i and negative 2i. So 2 is an answer, 2 is an answer a second time, 2i and negative 2i count as the other 2 answers. That's a total of 4 answers altogether, which is how many we're expecting. And again, if an answer happens more than once, that's multiplicity 2 is how we write it. So as far as writing the answers out, x equals 2 multiplicity 2, comma 2i, comma negative 2i. Those are my solutions. So since find all the zeros, that's the answer to that question. For the other thing, it says write the polynomial as a product of linear factors. So this direction here, I'm going to write p of x equals, I want to name it p of x because that's what my polynomial is called. And the way I take my solutions and write it out in factored form is x minus each answer, and any multiplicity represents the power of that factor. So 2 multiplicity 2 tells me x minus 2 is a factor. Multiplicity 2 means the factor has a power of 2 on it. I'm going to get x minus 2i and x plus 2i. And what I'm doing each time again is x minus each answer for my factored form. X minus 2, x minus 2i, x minus negative, so plus 2i. So this would be the factored form of my polynomial also.